Hello, Math 2. This video is for Unit 9, Lesson 2. I am going to do this video in two parts, so if you missed class, make sure you watch both parts. This part is just to talk about and discuss addition and subtraction of complex numbers, and then part B video will do multiplication of complex numbers. So we're working on operations with complex numbers today. So a complex number is a number that can be written in the form of a plus bi, where a and b are real numbers. So the a is called the real part of the complex number, and bi is the imaginary part of the complex number. So we had some numbers like this coming up in our equations that we were solving last class. So something like 5 plus 2i is a complex number, where 5 is the real part and 2i is the imaginary part. A and B can be any real numbers, though, so it could be fractions, 1/2 plus 7/2 I. It could be roots. It could be the square root of 5 plus I root 7, something crazy like that, as long as you've got a real part and an imaginary part. We say that a complex number is in standard form when the real part comes first and the imaginary part comes second, and both parts are simplified. So I have some examples of complex numbers. Some of these are in standard form and some of them are not. I'll just go through the list and kind of talk about which ones are and aren't. So this one is in standard form. It has the real part first of 7 and the imaginary part, negative 6i, comes second. And like I said a second ago, it's okay if those numbers are fractions. It is still in standard form if you have the real part first and the imaginary part second. Okay, so let's look at these two that come next. So part of being in standard form is that it should be written in simplest form. So these two numbers are both real numbers that have a 0 imaginary part. If you have 0 imaginary part, you don't want to actually write the 0i. Kind of like if we have a polynomial x squared plus 0x plus 7, we don't really want to write that middle term with the 0. It's not considered simplest form if it has that. So these are both complex numbers that have only a real part and 0 imaginary part. Standard form would be in simplest form, like negative 19. This one in simplest form, it would just be a negative 8. So negative 8 minus 0i would not be considered simplified, so not in standard form. Okay, we have another number here in this next one, negative I minus 3i, that is not simplified. So this has, right now, it looks like it has two imaginary parts, but those two can actually be combined together. If you have a negative 1i and a negative 3i, that's the same as negative 4i. So we would want to combine those two imaginary parts together and simplify that. So that one was not in standard form. Okay, negative 9 plus I, that is definitely in standard form. It has the real part, negative 9, and it has an imaginary part of 1i. Okay, the next one, 4i plus 11. That's definitely a complex number, but it is not in standard form. Standard form would have me put the real part of 11 first and the imaginary part second. So this one had the order wrong for standard form. Okay, the next one, it is almost in standard form. It is a complex number, 5 plus 4i plus 6. However, if you have multiple real parts, you should combine them together. So this is also 11 plus 4i. It was not simplified, though, the way it was written at first. Okay, so now we have 0 minus 2i, and part of being in standard form is that it should be simplified. So it's unnecessary to write that 0. So we would just say that in standard form, this is negative 2i. And 20i that comes next, that one is just fine. It has a 0 real part, and it's unnecessary to write that 0 real part. Okay, this one is a little bit tricky maybe. 1 minus 12i is being squared. Now, this is an imaginary number that's being squared, but it turns out that that is going to give you the answer of an imaginary number. In a minute, I'm going to show you how to multiply that out, but it is negative 143 minus 24i. So as written with the power, it is not in standard form. We could put it into standard form, and we will show you how to do that in a minute. Okay, our last one is 7 minus I root 2. Now, sometimes people will get confused with the I in front of the root 2 here, but for standard form, what's important is to have the real part first and the imaginary part second, and we do have that situation happening. The I is fine in front of the root 2. That is considered probably best practice for writing these, because otherwise it can look like that I is under the root, depending on how fantastic your handwriting is. So it just avoids ambiguity with our handwriting if we put the I in front of the root. So that one is in standard form. So as we go through this unit and work with complex numbers, we want to make sure that we are putting our answers into standard form. So whenever you finish adding or multiplying complex numbers together, just kind of look at your answer real quick and just check, mentally, did I have my answer in standard form, or do I need to combine some terms or change the order so that the real part comes first? So the complex number system, it includes all of the real numbers. Those are the ones that have a 0 imaginary part, and it includes all the imaginary numbers. Those are the ones that have a 0. Sorry, I think I said that wrong. I don't know. The real numbers have 0 imaginary part. The imaginary numbers have 0 real part. Complex numbers include all of those that, potentially have a 0 part, and then it includes all of the ones where they're not a 0 part as well. So as we add and multiply complex numbers, it turns out that if you add two complex numbers together, you get another complex number. If you subtract a complex number from another complex number, you're going to get an answer in this system as well, a complex number answer. And if you multiply two complex numbers together, you will also get an answer that is a complex number. So it's a closed system for addition and multiplication. We're going to worry right now about adding complex numbers together. Addition of complex numbers follows the same rules as polynomials. Essentially, we combine the like terms. For complex numbers, what like terms would be is that real parts combine with other real parts, and imaginary parts combine with other imaginary parts. And then, of course, we want to make sure we report all of our answers in standard form. So this first example, 5i plus 6i, that only has two parts that are being added together, and they are both imaginary parts. So they would add together to each other just fine, and we would get the answer 11i. This next little addition problem has four terms. We've got a 2, a 15i, an 18, and a 4i. So you just want to identify maybe all the real ones. We've got two real terms, 2 and 18, and we add those together and get 20. And then we've got two imaginary parts, and those two can add together as well. So we've got a 15i and a 4i, and that's a total of 19i. So 20 plus 19i would be our answer, and that is in standard form. Sometimes you'll have negatives come up, so just, be extra careful as you're handling your negatives. Our real part in this one is 3, and our real part here is -7. We're adding those two parts together, so our real part is -4. Our imaginary part on this complex number is I, which is 1i, and our imaginary part here is -5i. So if I add together 1i and -5i, I get -4i. Don't let the parentheses here throw you off. We are not multiplying. The operation is adding. The parentheses are just showing the two complex numbers. So 3 plus I is the first complex number, and I'm adding it to the second complex number, which is -7 minus 5I. Parentheses don't mean timesing. Parentheses are just a grouping symbol. It's just saying, hey, take this number and add it to this number. Okay. Subtracting really works almost exactly the same way as adding, especially if you've been adding with negative coefficients. Just make sure that, I guess the thing to be extra careful of is that this subtraction symbol applies to the real part, and it also applies to the imaginary part. So this complex number has two parts. The subtraction applies to each of them. So just be careful to apply it to both parts. So there's a couple ways you could write this. I'm going to show you the two ways on this video so that you can kind of decide which one you like better, or maybe one of them is a way that your teacher's written it in the past. So one way is to rewrite all the terms, 5 minus I, and then just mentally think about, okay, I'm subtracting a -7 and I'm subtracting a 2I. So if you like doing it this way, if you don't like remembering, oh, I need to change things, sometimes if you're thinking about changing things, it gets confusing, but you can write 5 minus -7, and that's the two real parts, real and real. So 5 minus -7 is the same as 5 plus 7, which is 12 for the real part. And the imaginary part, I've got a -I and I'm subtracting 2I, so that's -3I. So this, sorry, excuse me, this subtraction ends up giving us 12 minus 3I as an answer. Another way some people like to do is to kind of think about distributing, and they sort of distribute and they change the minuses to pluses, and if there was a plus, they would change it to a minus. So like on this problem, if I did it this way, I would change this to a plus, and then this one would become a minus. So if you like to kind of write it out that way, you can. Okay, so let's finish up this second problem now. So I've got a 6 as a real part, and then I have a 1 over here as a real part, so that adds together to give me 7. And then I have, for my two imaginary parts that need to combine, a -8I and a +6I. So those two imaginary parts combine to give me -2I. Okay. I'm going to end the video here for the adding and subtraction part of it. If you work on your worksheet, here's some answers that you can check off. Little typo on that one, sorry. You can use these to check. They have been shuffled, so just look for your answer on the list, and if it's there, you'll know you did the problem right. And let me or your teacher know if you're having any problems with that. Make sure if you missed class that you also watch the second video, which will teach you how to multiply complex numbers. Thank you.